August, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again, after months of spouting gibberish.
We thought we knew our solar system, until Voyager 2 broke through the edge and saw something no one predicted. Beyond the planets, past the icy Oort Cloud, it found signs we might be floating inside a massive cosmic bubble. And when it crossed that final boundary, the data left scientists stunned. Plasma vanished. Particles shifted. Was it a wall, a shield, or something watching us? What Voyager 2 saw out there changes everything, and you're about to see why. Voyager 1.
It was the first time that any spacecraft had made the 4 billion kilometer journey, and very little was known about this gas giant at the time.
On the 20th of August 1977, scientists sent out a powerful spacecraft to see the universe beyond what we saw. Soon enough, it crossed out of the heliosphere, the sun's protective bubble. But right there, Voyager 2's instruments caught a sharp drop in solar wind, a spike in energetic cosmic rays, and a distinct magnetic field shift. These were all signs it had entered a new region of space, somewhere no one really understood. But before we can fully understand the astounding discoveries made by Voyager 2, we have to start from the very beginning.
1977, the Voyager 2 space probe began an incredible lifelong journey that would take it all the way through our solar system and beyond. Today, the space probe is some 20 billion kilometers from Earth.
From Voyager 1. In the late 1970s, NASA decided it was time to send a messenger on the ultimate road trip to the outer reaches of our solar system and, if everything goes well, beyond. That messenger is Voyager 1, launched on the 5th of September 1977 from Cape Canaveral. It's actually part of a duo sent up just after its twin, Voyager 2. But why launch 2 probes? Turns out there was a rare planetary alignment. Jupiter, Saturn, Uranus, and Neptune lined up just right. So they decided to just take a grand tour. Now, beyond just traveling through space, Voyager 1 had a purpose to fulfill, and it needed numerous instruments to carry out such a delicate operation. Cameras to photograph the planet and its satellites, a radio science system to determine the planet's physical properties, an infrared interferometer spectrometer to check energy balance, an ultraviolet spectrometer to measure atmospheric properties, and a magnetometer to analyze each planet's magnetic field. They also thought to include a plasma spectrometer to investigate microscopic properties of plasma, ions, and a low-energy charged particle device to measure fluxes and distributions of ions. Trust me, it looks even cooler than it sounds. Each one of these was designed to collect a unique piece of data about what it passed through. On the other hand, for NASA to communicate with Voyager 1, it used something called the Deep Space Network.
One in Spain, one in California, and another in Australia, 120 degrees apart, so together they could see the whole sky 24 hours a day.
It's a chain of massive antennas scattered across Earth, ready to catch faint signals from the farthest spacecraft we've ever built. Decades later, Voyager 1 is still talking to Earth. It's the most distant human-made object, somewhere far beyond Neptune, drifting into the unknown and sending data home. Engineers update its software from time to time, turn off non-essential systems to conserve power, and keep its antenna pointed our way to squeeze out every last drop of data. But after spending almost 60 years in space, what did scientists see through the eye of Voyager 1? Its adventures started on Jupiter. Voyager 1. Bypassing Jupiter. Before Voyager 1 or 2, Jupiter was thought of as a lonely gas giant without rings. Well, Voyager changed that. It revealed swirling belts and zones around Jupiter, painted in rusty reds and creamy whites. These weren't just bands, but active storms just twirling around. Then came the unexpected, lightning on Jupiter. Voyager 1 detected radio signals called whistlers from the planet's night side, then spotted flickers of light where clouds were zapped by lightning. In fact, this was the very first observation of lightning beyond Earth. But maybe the most jaw-dropping find was the volcanoes on Jupiter's moon Io. On its closest pass, Voyager 1 caught images of active eruptions on Io, also making it the first time scientists had ever seen volcanic activity on another world.
And they saw something really weird. They saw this arc next to the moon.
They were massive plumes of sulfur dioxide and lava flows completely reshaping the moon's surface. In a blink, Jupiter became even more intriguing via two new moons, Thebe and Metis. Voyager 1 discovered these tiny satellites and added to Jupiter's already crowded family. By looking back toward the Sun, it spotted a delicate, dusty ring circling the planet. Turns out, ring systems weren't just Saturn's thing after all. Voyager's instruments also mapped Jupiter's magnetosphere and radiation belts. It found the magnetic field was far stronger than we'd guessed, with intense regions of charged particles zooming around. It's hostile territory for future missions, but fascinating for us. Finally, Voyager 1 gave us our first close-up looks of Jupiter's major moons. The first is Europa, a smooth, icy world crisscrossed with dark cracks. That hints that something was moving beneath that shell.
First glance looks like a lifeless frozen sphere. Its surface crisscrossed with endless scars and brownish ridges.
The second is Ganymede's surface, divided between cratered areas and grooved terrain. Then there was Callisto, a battered, heavily cratered world like a time capsule from the solar system's violent early days. Finally, Amalthea. Voyager 1 got a close-up of this little oblong moon too, and gave us our first real look at one of the inner irregular moons. On Saturn, however, things were quite different. Voyager 1, bypassing Saturn. It's the 12th of November, 1980, and Voyager 1 swoops past Saturn, getting within about 124,000 kilometers of its cloud tops. That's closer than any human-made object had ever been before. And what did it find? A whole world of surprises. First off, Saturn's atmosphere turned out to be nothing like Jupiter's. It's mostly hydrogen, with only about 7% helium, a lot less than you'd expect from comparisons to Jupiter or even the Sun. Scientists thought that heavier helium might be sinking deeper, explaining why Saturn gives off more heat than it receives. Voyager 1 saw winds blasting along at around 1,100 miles per hour near the equator and even discovered alternating east-west jets at mid to high latitudes. Even more baffling, it discovered a hexagon-shaped storm encircling the North Pole, and it is indeed quite massive. About 29,000 kilometers across, with jet stream winds ripping along its edges. Next were the rings. Voyager 1 captured the most detailed images yet, revealing that Saturn's rings are made of countless ice particles, from those as tiny as dust and chunks as huge as an entire house. The rings are home to intricate structures, lots of ringlets and faint gaps you can't even see from Earth. And then there were the spokes, ghostly radial features in the B-ring that appeared and vanished over time. Scientists think electrically charged dust might indeed be floating above the ring plane. But till today, they're still figuring it out. The most fascinating of them all, however, is how Voyager 1 captured and discovered a brand new ring. The G ring, a faint icy band lurking beyond the main rings. It also discovered 3 new small moons during the flyby, bringing the count up to around 15 at the time. There were some striking surfaces too. Mimas's giant crater that makes the moon look like the Death Star, Iapetus's two-tone color, and Enceladus showing surprisingly smooth terrain. Now, before it finally dipped past Saturn, Voyager 1 picked up mysterious radio bursts, which scientists named Saturn electrostatic discharges, looking a lot like lightning, but 10,000 times more intense than earthly equivalents. These storm signals probably came from deep convective weather systems, another first in planetary weather observation. Experts had never made such a research-altering discovery as this one, and Voyager 2 was about to reveal even more mysteries about the world beyond our planet. Voyager 2, bypassing Jupiter. Voyager 2 is Voyager 1's twin spacecraft, but its journey was very different and even more adventurous in some ways. It actually launched a little earlier, but arrived later on the 20th of August, 1997, but took a slower path.
High enough to hit a passing satellite. Voyager project scientist Dr. Edward Stone.
If I were to pick one discovery to represent the body of discoveries that Voyager's made, I would pick the discovery of the volcanoes on Io.
Unlike Voyager 1, which only visited Jupiter and Saturn, Voyager 2 is the only spacecraft in history to have visited all 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. Voyager 2 got much closer to Jupiter's moons Europa and Callisto, so close that scientists could pick up details Voyager 1 couldn't. On Europa, instead of deep cracks, Voyager 2 revealed flat lines, meaning there's a thin, icy crust, possibly floating on an ocean beneath. Voyager 1 had already spotted the moons Adrastea and Metis, but Voyager 2 added to the family with a third discovery, Thebe. While Voyager 1 gave us the first close-up of the Great Red Spot, that raging storm, Voyager 2 noticed that it had drifted, shifted in shape, and changed color, all in just a few months. Maybe Voyager 1 discovered the volcanoes on Io, but Voyager 2 tracked how they changed, confirming that volcanic activity on Io is wildly variable.
Slams into Jupiter's magnetic field. The spacecraft's instruments recorded a strong bow shock.
Now, even decades later, scientists reanalyzed Voyager 2's magnetometer data and discovered jets of plasma like energetic rivers of charged particles flowing in Jupiter's magnetic boundary. That's a phenomenon we'd seen on Earth and Mars, but never Jupiter. Voyager 2, bypassing Saturn. Voyager 2 zoomed about 23,000 kilometers closer to Saturn than Voyager 1 did, landing at about 63,000 miles from the giant planet. That extra proximity meant more detailed views and some surprises that Voyager 1 didn't catch. Voyager 2's photopolarimeter worked where Voyager 1's failed and let scientists peer into the rings with much finer resolution. It uncovered previously unseen ringlets, tiny gaps, and intricate structures. In fact, Voyager 2 saw structures so fine and dynamic that they looked like a cosmic ballet in motion. Voyager 2 also added to Saturn's moon tally, discovered new tiny satellites, and provided better images of known ones. It spotted Helene, Telesto, and Calypso. along with the previously known Hyperion, Enceladus, Tethys, and Phoebe. Now, when Voyager 1 flew past Saturn, it gave us a little tease of Enceladus, the tiny icy moon with a bright, young-looking surface. But then came Voyager 2, and it really pulled back the curtain. Its sharper, higher-resolution images showed us that Enceladus wasn't just another dull, frozen rock. The moon had a mix of cratered areas and smooth patches of terrain, a clear sign that something inside was shaping its surface. This could only mean that there was internal activity, which was shocking because moons that small usually aren't geologically active. What Voyager 2 saw laid the groundwork for what the Cassini spacecraft would later confirm.
Saturn's moon Enceladus could have saltwater-driven currents similar to those on Earth, according to a theory proposed by scientists from the California Institute of Technology and NASA's Jet Propulsion Laboratory.
That Enceladus hides a global ocean under its icy crust, and even spews out giant plumes of water vapor into space. Near Saturn's equator, Voyager 2 clocked winds at almost 500 meters per second. That's over 1,100 miles per hour. These winds weren't just surface deep either. The jet streams appeared symmetrical north and south, which suggested that Saturn's winds go far deeper into the planet than anyone thought at the time. And then there was Saturn's strangest feature, the hexagon at the North Pole. Voyager 1 had hinted at something odd up there, but it was Voyager 2 that delivered the first clear, undeniable images of a gigantic six-sided jet stream wrapping around the pole.
Gas. This means that the vortex here can be very symmetrical and orderly, governed by only atmospheric forces.
Imagine a hurricane bigger than Earth, but perfectly shaped like a hexagon. That's what Voyager 2 revealed. Decades later, even with Cassini's detailed follow-ups, scientists are still scratching their heads over how exactly this giant storm keeps its shape. Voyager 2 also caught something nobody had ever seen at Saturn before: auroras. These are glowing ultraviolet emissions that appeared at both the poles and at mid-latitudes, which was surprising because auroras on Earth usually hug the poles. Along with that, Voyager 2 was what helped experts pin down Saturn's day length to about 10 hours, 39 minutes, and 24 seconds. Voyager 2. Bypassing Neptune. To be clear, Voyager 1 never even got close to Neptune. No flyby, no snapshots, nothing.
By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune.
Voyager 2, on the other hand, swooped in on August 25, 1989, becoming our first and only spacecraft to visit the distant blue world. Voyager 2 showed us that Neptune isn't just a calm blue marble, it's actually wild. It captured the Great Dark Spot, a massive storm roughly the size of Earth, with winds screaming at up to 2,100 kilometers per hour, the fastest in the whole solar system. But surprisingly, a second storm, the Small Dark Spot, made an appearance too. In the upper skies, it's a speedy, bright little cloud nicknamed Scooter that is closely related to the Great Dark Spot. Voyager 2 also discovered 6 new moons: Naiad, Thalassa, Despina, Galatea, Larissa, and Proteus.
That is Proteus. And it is worth taking a look at it and seeing what would it be like to stand on this forgotten moon.
In particular, Proteus stood out, and that's because it's huge for an inner moon, shaped like an irregular polyhedron, heavily cratered and super dark, like cosmic charcoal. The most significant moment, however, was when Voyager 2 gave us our first real look at Triton, Neptune's biggest moon. It's geologically active, even though it's colder than just about anything else. Voyager 2 saw geysers erupting dark nitrogen plumes, a super-thin atmosphere, and polar caps. All signs that Triton was completely different from what scientists thought it was. Voyager 2. Bypassing Uranus. Just like Saturn, Voyager 1 never flew by Uranus. Voyager 2 is still the only spacecraft ever to have visited Uranus, zooming within about 50,600 miles of its cloud tops on January 24, 1986. That same year, Voyager 2 first discovered 11 brand new moons on this planet, including Cordelia, Ophelia, Bianca, Desdemona, Juliet, Portia, Rosalind, Belinda, Puck, and Perdita. It also snapped the first ever images of Uranus's faint, dark rings, and even found 2 rings previously unknown. One ring in particular, the Lambda ring, stood out in ultraviolet data, revealing surprising particle patterns and fine structures, along with a waviness that puzzled scientists. Plus, reanalysis of Voyager's images today suggests there might be tiny moonlets stirring up ring waves, so subtle that we still haven't actually seen them. Uranus's magnetic field was nothing like expected. Voyager 2 showed that it was tilted about 59 degrees off axis and not even centered. It was unlike anything seen before. Even the magnetic tail is twisted into a corkscrew, stretching millions of kilometers behind the planet. Recently, scientists realized Voyager 2 actually flew through Uranus's magnetosphere during an unusual solar wind event that compressed its protective bubble to only 20% of its normal size.
It is also tilted at an astonishing 59 degrees. That means its magnetic and rotational poles are not at all in the same place.
Of course, that skewed early interpretations of its magnetic environment. Decades later, researchers then discovered a plasmoid in the data, a giant bubble of charged gas possibly carrying Uranus's entire atmosphere off into space. Voyager 2 also found that Uranus is the coldest planet in the solar system. On an average, it is minus 320 degrees Fahrenheit, with virtually no internal heat. It also detected heat transfer from pole to pole, keeping both sides at similar cloud top temperatures, even though only one side was sunlit for decades.
This small, lumpy moon features a surface covered with skewed and interesting ice slabs.
Then there's Miranda, Uranus's innermost large moon. Voyager captured jaw-dropping images of its fractured terrain, dramatic cliffs up to 20 kilometers high, and chewed-up surfaces. Scientists say that it must have had a violent past, maybe even broke apart, and reassembled itself. The Interstellar mission, Voyager 2. Voyager 2 did not stop exploring after its planetary flybys. It went a little further. After Uranus and Neptune, it embarked on its interstellar mission, becoming only the second human-made craft to cross into interstellar space.
It will take the spacecraft about 300 years to reach the inner edge of the Oort Cloud, and then another 30,000 years to emerge from the other side.
The first was Voyager 1 in 2012. Voyager 2 followed in November 2018, and crucially, it still had a working plasma science instrument, which Voyager 1 lacked by then, giving scientists richer and more detailed data. Some of the findings reflect how odd and dynamic the edge of the solar system is. Voyager 2 first observed extra layers beyond the heliopause, regions of compressed plasma and shifting magnetic fields, revealing that the boundary is far more complex than scientists once thought. It also found a transition so sharp and defined between the hot, sparse heliospheric plasma and the colder, denser interstellar medium that it challenged long-held ideas of a gradual fade-out. Voyager 2 also showed us that the interstellar magnetic field aligns startlingly well with the heliospheric one, suggesting a more coherent cosmic magnetic neighborhood than assumed.
This narrow window gave NASA a strict deadline. There wasn't enough time to plan follow-up missions, and the United States Congress wouldn't earmark enough funding for a longer expedition, like the grand tour NASA first proposed.
Voyager 2 also helped us realize the solar system's shape. By crossing the termination shock at a different distance than Voyager 1, about 1.6 billion kilometers closer to the Sun, it showed that our heliosphere isn't round, but dented, compressed by interstellar forces. Plus, its plasma instrument measured astonishing particle behaviors, lower than expected temperatures beyond the shock, streams of high velocity, and non-thermal pickup ions. The golden record. Now, of all the things that Voyager 1 and 2 set out to achieve, this is probably the most interesting.
In 1977, NASA sent 2 golden records into space.
On each spacecraft is a little time capsule made of copper, plated in gold. A 12-inch phonograph record meant as a message in a bottle to aliens who might find it out there among the stars. They called this message the Golden Record. A team led by the astronomer Carl Sagan, and that included his wife, Linda Saltzman Sagan, as well as Tim Ferriss, Annie Druyan, Frank Drake, John Lomberg, and others, had under 6 months to decide what should go on this record. After a while, they came to a conclusion. The first item they added was a tape of what Earth sounded like: surf, thunder, birdsong, whale songs, and even human sounds like footsteps, heartbeats, a kiss, and thoughts captured from brainwaves.
Sleeping with the wrong person or eating the wrong food on the wrong day, things like that.
Annie Druyan, who was the creative director, insisted on conveying the full emotional palette of humanity, not just the sunshine. So she recorded her brainwaves while thinking about fear, love, anxiety, and then compressed an entire hour into 1 minute of audio. They also included a sweet mix from several cultures and eras: Beethoven, Mozart, Bach, Chuck Berry's Johnny B. Good, African drumming, Peruvian wedding songs, and electronic pieces by Laurie Spiegel. They then went ahead to record a tape of spoken hellos in 55 languages, from ancient Akkadian to Wu Chinese. There's even a greeting from UN Secretary-General Kurt Waldheim, and a personal one from Sagan's 6-year-old son.
Untouched by these remote events, the Voyagers, bearing the memories of a world that is no more, will fly on.
There are also currently 116 photos and diagrams present on both spacecrafts. A silhouette of a couple, human anatomy, DNA, architecture, like the Taj Mahal, Olympic sprinters, and the Golden Gate Bridge. And just in case the aliens don't read, there is a guide on how to play the record and how to find Earth. So with 2 history-making spacecrafts out there, forces outside our world could find their way to us, and it could be sooner than later. Share your thoughts in the comments section. And don't forget to like and subscribe for more content about the world beyond. See you in the next video.